All right, hello everyone. My name is Aiden Waldron, and I was a civil site intern at Lowe Engineers this summer. And in this video, I'm just kind of gonna break down some topics of what I learned and some lessons and some mentors and whatnot. So let's get started. All right, so a little bit about Lowe Engineers. We started out in 1957 in Atlanta, Georgia. That's where our headquarters is. As I'll talk about in a second, we have three different main offices. However, our headquarters, like I said, is in Atlanta, Georgia. And we provide a lot of services here. Some of them include surveying, civil engineering, which of course, what I do in terms of civil site. We also do highway, roadway, bridge design, which is in the transportation sphere of civil engineering. We also do utility systems analysis, hydrology and hydraulics, which is also in civil engineering. Same with waste and wastewater, or water and wastewater system designs. And we do planning, aerial mapping, and some photo work. And that really goes hand in hand with GIS and surveying. Now we have a lot of core values here at Lowe Engineers. One of them is go the extra mile, do what we say you're going to do, professionalism, relationships and values, and believe in a glass half full. Out of all these, the ones that I see the most in the workplace was go the extra mile and relationships slash value. In terms of go the extra mile, having only 3 people, not including myself, on the civil site team and having over 12 projects going on in that organization, there's a lot that has to be done. So there are some days that we're there till 8 o'clock, 9 o'clock, having to get things done. Same with relationships. I've never seen a company where they do so much for employees. They bring in a bunch of food for lunch. It's just amazing. In terms of the organization as a whole, we have around 150 employees plus 10,000 projects over the entire history of Lowe Engineers. And again, like I said earlier, 3 main offices. And we have some major projects here. One of them is Children's Healthcare, the Arthur Blank Healthcare thing in Atlanta, Atlantic Station, Mercedes-Benz Stadium, and of course the Mercedes-Benz headquarters. Now some mentors and supervisors. My supervisor being Bill Aguilar. And if you see my cursor, he's right here in this photo in the bottom right-hand corner. He's the civil site manager. He has PE license. He got it in 2000 for Georgia. He previously worked at Kimley Horn as a senior project manager, and he specializes in everything land development wise. My other mentor, or my mentor actually, is Jake. He's a project manager. He graduated from Purdue University. He has the FE. He specializes in grading and storm water design, and he previously worked at Gaskins and LaCroix. My next mentor was Adam. He's a project manager as well. He graduated from Savannah State University and is currently working towards his FE. He actually didn't graduate with his FE when he got out of college, so he tells me all the time, make sure you get the FE before you graduate, or you're going to be like me, studying it for it 10 years, 20 years down the road. He specializes in erosion control and hydrology, and he previously worked at Travis Purett and Associates. I probably butchered that, but he talks about that company a lot and how much he loved it. Now, the responsibilities and tasks I completed. I completed a lot of different tasks throughout my time here at Lowe Engineers. One of them being erosion control BMP code placement through the GSWCC manual. BMP just stands for Best Management Practices. This can include things like an LOD, which is limits of disturbance. That goes around the entire site because you're enclosing whatever grading or disturbance you're doing to the soil. You also have your silt fence, which catches the runoff water, and you have your tree save fence that protects trees if they're on site. Some other stuff can be sediment traps for catch basins or sediment traps for drain inlets. That kind of stuff is what goes into erosion control placement. And I did septic design. I didn't really think I was going to do this because all in all, I did not know that civil engineers even design septic. Having said that, at Lowe Engineers, I've kind of became the main person for septic because I've taken some diligent time to learn what actually goes into designing septic. You learn all of that in the Department of Public Health manual for on-site sewage management systems. It's great. Usually what goes into it is if you're doing, let's say, a residential site, you get your geotechnical report that tells you what your percolation rate is, and you go into the manual and you'll find some what's called an absorption field rate You'll do some math. You'll find out what your linear feet is for your primary and secondary field. You either use chambers that you can get from ADS or you use PVC pipe, and then you'll set them up in the backyard or the front yard, depending on what your site looks like. You'll send it to the Department of Public Health, and they'll either deny you, give you some comments, or they'll approve you, and then you can start putting septic on that site. The next thing is super simple, viewports, setting up sheet sets. I learned this kind of my freshman year in my civil graphics class. However, this is a good kind of reminder of what viewports were and how you set up sheet sets. The real important thing here was to not really overlap a lot and make sure you're showing the entire site without cutting things off like a pond. The next thing I did was engaging with clients and reaching out to geotechnical engineers for proposals. This kind of had to do with engaging with clients in that part. I had a meeting every Tuesday with Rosemary Estates. I'll talk a little bit about that in a second, where we kind of sat down and talked about the project and where it's going and what needs to be done on our side going forward. And the second part of that, reaching out to geotechs. We have this project coming on right now called Harbins, where it's 38 lots and it needs septic on each lot. Having said that, in order to get approval from Georgia Department of Public Health, you have to have a level 3 soil report. In doing that, you have to have geotech engineers come out to the site, do some boring, and test the soil for its percolation rate. Now, the next thing I didn't do much of, but I did some of it, was putting together concept drawings. And I go a little more detail, and I go into a little more detail about that in a second. But basically, we're just putting drawings together to kind of give a picture to the client to see what he or she wants to do with the site that they have. Next one was training within Civil 3D. This is kind of self-explanatory. You know, I haven't had much work in Civil 3D. The only work that I have had is my freshman year. So kind of remembering tools like a polyline, line, fillet, mirror was really important. And then fixing up drawings with a set of markups from my supervisor. You know, Bill would give me some drawings a few times out of the week, which is some simple markups that he needed to be fixed before sending them out to a client. Now here are some project highlights. The first one was Cherokee County, Woodruff Park. This project has been going on for a pretty long time. Now it's actually, I think it's pretty close to getting approved finally after going through 5 different stages of comments from the county. I actually got a septic system approved on this site, I was very proud of myself. Fixed up that site a lot because as I was talking my lessons section, a lot of the layers were messed up and needed to be fixed, including surfaces. So yeah, hopefully that will go out soon and we'll be able to see it being built very soon. Next one was Giverny. Giverny is this 200 plus acre site with a multitude of houses, kind of townhomes and single family homes. These homes are probably going to be ranging from the millions, to be honest. It's out in Fairburn. It's a really cool gated community. It's going through 3 different phases. So the first 2 have already gone out. Its first one was clearing and grubbing. Second one was just phase 1, and the third one is just phase 2. You know, hopefully in the next coming weeks, I'll be able to actually go on site because I haven't been able to go on site at all this semester, or actually this summer. So that'll be good to get outside finally, because I did surveying last summer and I was on site every single day. So having the opportunity to go on site and actually do something is going to be awesome. Next one's Rosemary Estates, was actually the pictures to the right. This is the product that's also been going on for a long time. And in my previous slide, I talked about how I have meetings with the client every Tuesday. This is just exactly that. I can kind of tell you about some of those pictures. So these pictures are kind of outdated here. The houses are actually moved back because the septic design was too large. As an example, the more bedrooms you have and basically the bigger footprint of the house you have, the more leach field or the more linear feet you need for a house. So these houses were originally, I think, five bedrooms or 6, and they were downsized to either 4 or 5, depending on what they originally were. And they were pushed back to give area in the front yard for septic. I know for this first house, we have the primary field right here, and we have the secondary leach field right here. Right here, we have an underground detention system that Adam designed. Can't really see in this photo. And then some septic all around the backs of these houses, basically. And then there's a stream in the back. And you see these lines right here. These are what are called buffers. Usually in Georgia, you're not allowed to build in these buffers. And the next project was TIG Night and Highway 81. This project I really just did a bunch of concept drawings for, and I have some examples of those in a couple slides down the road. And the next one was Harbin's Road. This had to do with a project, I think down in Gwinnett County. It's 38 lots, and I had the opportunity to design the septic tank systems on every single lot. And as of now, we are about to get some proposals in from some geotechnical engineers and decide which one the client wants to do, so we can actually design the septic systems to what the soil types are in the field. Now, getting into the relation of tasks in civil engineering coursework. The first class that I want to talk about is surveying. Now, in this class at Kennesaw, I'm taking the second class right now, next semester. You know, in the first class, we learned measuring distances, elevations, angles, reading plats, topo maps, legal descriptions. We learned concepts like traversing, benchmarks, coordinate geometry. And having all said that and doing my surveying internship last summer, if I didn't have any of that background, I think it would be literally impossible for me to have grasped the concepts that I've learned this summer. You know, being able to read a surveying plat, being able to read what a topo map is in terms of the existing grade is super important when you're either grading or doing drainage or trying to understand what's already existing on the land. You know, if I didn't know what a catch basin was, if I didn't know what a drain inlet, if I didn't know what an IPF is, which is the iron pin found, then I think it would be pretty hard for me to grasp the concepts that I learned this summer in terms of land development. Second class I want to talk about is fluid mechanics. Now, the main thing that I learned this class was flow rates, head loss, open channel flow, velocity, pressure, system design. And now out of those topics, probably the most important ones I've used this summer is channel flow and flow rate calculations. You know, for an example, let's say we have a crown on a road and the water is going to the left and to the right of the road, and there's no curb and gutter. So it immediately goes into what we call a ditch. That ditch is technically an open channel. It can be a parabola, it can be a triangle, or it can be a trapezoid. Having said that, knowing the information from my fluid mechanics class and using the software on Civil 3D, I can figure out what the flow rate is. I can figure out what the curve number is. I can figure out what the runoff coefficient is based on the flow rate. Now, the next class was civil graphics. Now, this class I took in freshman year, so it's kind of hard to remember a lot from that class. But we did a bunch of AutoCAD and Civil 3D work. A lot of those same topics I learned in that class, I use every single day in my land development internship, whether it be doing viewports, knowing how to traverse around the system, knowing how to edit blocks, knowing what the layers are, knowing how to change from a color to a true color, knowing how to plot, knowing how to fit to paper. All those things I learned in my freshman class. So it would have taken a lot more hands-on learning in my land development internship, and it would have taken time out from actually working on projects if I didn't already know that information. Now, the next class I wanted to talk about is product cost analysis. Now, originally, you wouldn't think much of this goes in hand with land development, but kind of does. You know, in this class, you do a lot of stuff with price estimates, and actually, we did a lot of cut and fill. And in land development, a lot of what you do is cut and fill analysis. You know, you need to get the best price for the client. You want to try to balance the site in terms of cut and fill so you don't have to bring soil from off-site or bring soil off-site. That can be in the huge scale of things and all the things you pay for on a site. That can be so expensive for the client. So knowing how to balance the site and how I learned it on a small scale in my project cost analysis class and bringing over it to a huge scale like Giverny as a 200-acre size plot of land made the transition a lot easier than it would have been if I didn't learn any of that. And the last class I wanted to talk about was Intro to Civil Engineering. This is the class that got me into engineering, got me into civil. taught me what the disciplines were, taught me, how to make a good example of yourself, how to be a good learner, be responsible, be time efficient, organized. If I didn't know any of that, or even communication, I think it'd be impossible to do anything I did this summer. Communication is so important in any engineering, especially civil. For example, if you have one person grading and you have another person doing drainage, those two people need to communicate almost all the time, because depending what the grading is, that's going to influence how you drain a site. Let's say you grade a low point. Where you put a low point in a product, that's where you put a double wing catch basin. If the guy doing the drainage doesn't know that, then they might put a single wing catch basin there, and that site might flood up in that area. So yeah. All right, let's go to the next slide. Now, these are some lessons learned. All these lessons are very, very important, so I'm just going to go down the list. First one is good surveys make or break a project. I cannot say it's enough. We have had times this summer where a stormwater pipe was showing up as a sewer pipe. That's just not good. If you are trying to do storm and you're connecting to a sewer, and let's say that gets approved because the client doesn't know, then you are liable for that because you designed it. So having a good survey, knowing, what your right of way actually is really important. I'll go into a little more depth with that. For Cherokee County, we had a right of way that was just not surveyed at all. So we had to use GIS to basically put a right of way in. Next one is cut and fill affects cost and how you design a project. I kind of talked about a little bit of this in my last slide, but cut and fill can be really expensive. Earthwork can be super expensive nowadays. Moving soil off site, bringing soil on site. With Cherokee County, Woodruff Park, we had an issue like that where we had to take a couple extra weeks to balance the site because we were told the site was balanced and my boss figured out it was not balanced. So yeah. Next one's permitting knowledge is a must. I didn't know so much permitting goes into a project until I did this internship. You have your septic permit. If you have septic, you're not using sewer, you're using septic. You have to get a permit for that. Permit for utility. If you're connecting to a GDOT road, either a state road like Rosemary Estates I talked about in a previous slide, you have to get a GDOT utility permit and a GDOT encroachment permit for the entrance. You have to get a permit from the city. You have to get an LDP permit, which is a land disturbance permit. You also have to get an NOI permit, which is a permit from the NPDES website that basically says during all your erosion control, you are not dumping water into any kind of stream nearby. You have to get that permit if you're over an acre. And if you don't have that permit within 14 days of you doing things on site, disturbing land, then your site could get paused by the city. So knowing permits is probably the most important lesson I learned this summer. And the next one is staying organized in Civil 3D. I cannot say it's enough. You need to be organized. There's been times on a lot of projects, especially the Rosemary Estates project and the Woodworth project in Cherokee County. Those projects were so miscombobulated, layers on zero, everything on zero, surfaces were not data linked in properly. It was a whole mess. For instance, if you're trying to freeze something in a viewport because you don't want to show it, and when you have your annotations on a zero layer, you have your X site on a zero layer, or you have your O grad on a zero layer, and you freeze that annotation or you freeze that surface, it freezes everything. So having things on the correct layer and having your layers organized is so important. And that brings me into my next two. Communication is king and everything overlaps. I talked about this in the last slide too, about how grading and drainage go hand in hand. Talking things out between people, understanding what goes where, knowing what's happening from top to bottom from the site is important, not in terms of you understanding it on a personal level, but making sure that you understand it enough that you can explain it to the client, explain it to your boss, explain it to your coworker, explain it to a baby. You need to know what everything's happening on the site, and communicating that with your coworker is above all else. Now, other than that, let's go into some pictures of work that I completed. Now, these two pictures here are Giverny. The left one is the grading and drainage, and the right one is the overall site, or actually a detailed site picture. I'll go through some of what this is and what I did on them. The pink magenta box, or boxes, are what called match lines. You can kind of see them here with the dotted line. They're basically the viewport. This is a huge, I think, 1 to 100 scale. And the one to the right is a 1 to 40 scale, basically. So I'm just drawing the match lines in to show the engineer or my supervisor, Bill, how I designed the match lines and how I designed the viewports. Now, in the grading and drainage plan, these yellow and blue lines right here are the grade, the proposed, and the purplish ones are your existing. So when you grade, you really try to match the existing so you don't have to put a retaining wall in. Let's say you're 10 feet above and you're trying to do a 3-to-1 slope to existing 5 grade. If you can't do that 3-to-1 slope, you have to put a retaining wall. And you don't want to do that because concrete in this day and age is super expensive. Now, out of all these pictures, other than the viewports and the match lines, I did the key plan in the top right-hand corner, and I did some of the annotation and radius of these circles here and these fillet lines next to the cul-de-sac. Next ones are the last pictures I have from my time at Lowe Engineers. Top left is I did everything on that. That is the cover page for Giverny, finding out what municipality does water, what does sewer, what does fire, what does all the utilities, basically. What are the buffers, what is the area limits, finding those maps that you see in the middle. The first one's really easy because you can just go to Google Earth and use the snippet tool and get a picture. The other one's a FEMA map, and I could talk about that for ages because I think this administration is trying to get rid of FEMA, and FEMA is a must for civil engineers. FEMA tells you where your floodplains are. It's basically the area that is prone to flooding. And you can see right there in that picture, that kind of yellowish area, those are the twin lakes on site. Those are prone to flooding. So you have to do a flood study saying that any stormwater that is on site, any more impervious surface, is not going to increase the flood table and increase the risk of flooding. Not having FEMA, you can't get those maps. So kind of need FEMA. And in the next two drawings here are my concept plans I talked earlier that I did for TIG Night and Highway 81. The client basically wanted more parking and more retail space. So if we look at concept plan number 1, all of this in this right-hand corner, I designed. All of this right here, I designed this, and I designed all of this. The pond was already here. We left the open pond here, but she just wanted some extra space, basically. Because she's combining this ply and this ply into one. And the second concept drawing I have down here, she wanted some truck parking, which is right here. And we couldn't keep the same volume for the pond because the more impervious surface you add, the more volume you need in your pond. And based on the one we already had from the previous LDP submission, we cannot place it here. So we decided to do an underground detention pond system. And the only problem with this is that they can get super expensive, especially in terms of concrete and gravel. The one for Rosemary Estates was around $700,000. So that kind of puts into perspective of how much this one might cost. And it's around the same footprint as the one at Rosemary Estates. So depending on those considerations, the client will decide and get back to us. Hopefully they pick this one up here with the open pond so we don't got to do any extra work. But we'll see in the time coming. And I think that's it. So thank you for listening. I'm sorry for talking so long, over the 10 to 15 minutes. I had a lot to talk about. I really enjoyed this internship, to be honest. It kind of opened my mind into the world of land development because I always wanted to do structural engineering. So now knowing that I might want to do land development in the future and stay with this company kind of puts me in an interesting spot of what I want to do. So yeah, thank you for listening. Have a great one.